Factor analysis. So we'll start off with this topic. The goal of exploratory factor analysis is to explain correlation which exists among a set of observed variables, right, by uncovering a smaller set of more fundamentally unobserved variables, right. So there could be something which is underlying in the data amongst the unobserved variables which have a far-reaching effect on your variables, which is not usually observed, because if you're looking at the whole data it is not visible, but if you look at a small aspect of that data it makes sense. So these hypothetical unobserved variables are called as factors. So you're trying to create some factors out of some existing variables. Like for example, if you're doing some analysis, like although not directly connected with this, when you're doing something like feature extraction in data, it's basically talking about, can I identify whether this name is a male name or a female name? Yes, I can, by doing some extraction or feature extraction by extracting something like, is there a presence of something like a vowel in the starting alphabet in the name, or the number of vowels present in the name. So if I can take that as a numerical data, right? So number of vowels present in, say, Mohan, in the word Mohan. So if I say A and O, there are two, right? M-O-H-A-N, right? There are two vowels in my name, right? If I can keep on counting these vowels in everybody's name, if I have the data, and similarly, if I say that the names which start with a vowel, there I mark a 1 or a 0. And similarly, I can do feature extraction from all these set of data. Now, these are very small things, but if they connect together as a factor, it starts really talking about your dependent variable, that yes, whether this person is a male or female can be isolated, right? So your intention in exploratory factor analysis is to understand that hidden part, right? And the model is usually represented by xi is equal to a1 f1, say to f2 plus dash 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 plus ap fp plus ui, right? Where ui is the proportion of variable xi unique to that variable, not explained by the common factors, and xi is the ith observed variable. Fj are the common factors, so j can start from 1 to p, and p has to be less than k. So the FactAnal, so it's FACTANL, that is factor analysis function, provides maximum likelihood factor analysis. So you have to enter the raw data and you have to specify the number of factors you want, right? So it has the varimax rotation. So a typical function call would be like, you call the FactAnal function, pass the first object as the data, the number of factors as the second one, the rotation you have to specify whether it is varimax or not, and then you get your algo to run on this data, and you can save it in an object of your own preferred name. You can check the same thing as what you did in the previous case. You can check, so principal component analysis and factor analysis somewhere comes very close to each other, because we are dealing with dimensions over here. So the loadings can be checked, the plots can be done in the same way as what you had done over there, right? So the rotation includes varimax, promax, none, right? And there are other options, like when you want to do scorings, you can do a regression or a Bartlett to produce factor scores. You can use the covmat option to enter a correlation or a covariance preference, right? So you can say that. So in the previous case, you had said COR is equal to true or COR is equal to false, which did that. In this case, you can specify COVmat, whether it is correlation or covariance matrix, right? The factor.pa function, which is part of the psych package, offers a number of factor analysis related functions, including principal access factoring. So you have factor.pa, that's a function. Again, you have to pass the data, you have to pass a number of factors, you have to specify the rotation method which you want, which can be varimax or promax, and then you can it includes the maximum likelihood, iterated principal access, right? So when you come to the factor extraction method, there are these methods which are like the weighted least squares, generalized weighted least squares, and the minimum residuals, that is min-res. All these options are available. Now, statisticians tend to prefer the MLE approach because it is well defined from the statistical perspective. So maximum likelihood estimates, the generalized weighted least squares, right? The weighted least squares is somewhere coming close to the linear and logistic regression concepts and becomes more relevant to statisticians. Sometimes these approaches fail to converge, in which case the iterated principal access option is the one which works well most of the time. So if these don't work for you, you can opt for the principal access option, which usually works most of the time, right? right? So sometimes data might say error, couldn't find these many factors and all those things. So that's the time when you can try as a last option the iterated principal access. Now, when you're doing this exploratory factor analysis, you have to determine the number of factors to extract. So in this case, we said in the previous, what you can see on the screen, that 3 was mentioned. Or how did you arrive at that 3? Now, to get that decision, you have a different function which is called as n factors, which offers a suite of functions to aid you in this decision. So you have to just load that package n factors, and then you will use the IGN values, right? So you have to call the IGN function. You have to pass the correlation of my data, so you're passing the correlation grid, the whole matrix, and you're going to compute the distance between these, that is the IGN direct distance between these. And then you are trying to use a parallel function wherein you are saying subject is equal to n row my data, number of rows, the variance is equal to number of columns my data, and replicate 100 times percentage is equal to 0.05. And then you say n Scree, in which you're passing the IGN values which you had collected in the previous case, the matrix, parallelized matrix that you're going to pass, and you're just going to plot it first. There is a factoranalysisinr package which offers a large number of additional functions for exploratory factor analysis. This includes use of both qualitative and quantitative variables, right? So you have to load that package factoranalysisinr, and you can directly run a PCA on the data without specifying anything, and it will automatically generate the whole set of results for you and the object which you specify. The GPA rotation package offers a wealth of rotation options which goes beyond Varimax and Promax computations. So we'll see the application of factor analysis over here. So we'll load the data. So again, we're going to use the same old data, USA arrest data, and we're going to save that in USA, location USA list, right? So that's the data, and then we'll install the package n factors. So I have already got that installed, I guess. So I'll just check it whether I have it. N factors, yes, it's there. So I'm just loading that package. You will use a variable name in which you want to store the output of the IGN values which you are going to compute. So we're going to say IGN correlation function, and in that you're going to pass the USA data, right? So that will be stored in EV, and then you're saying AP, you're creating one more object wherein you're saying parallel. In that you're passing subject is equal to number of rows of USA, so it will be computed at runtime, and var is equal to number of column of USA. And spelling is parallel. Okay, so these two things are done. I guess we have to add one more parameter after the US. It's replicate is equal to 100 and cent is equal to 0.5, right? And then you're going to say n, the capital S, with this, because we're going to do a Scree plot. So I'm saying n Scree, in which you're going to say x is equal to the IGN values which you have computed, which is saved in the EV object, and then the A parallel is equal to AP dollar IGN dollar QE PPA, and then you just do an enter, and you say plot Scree, and in that you're going to pass this new object. So you'll be getting somewhere this is cluttered, but this is how it is. Okay, so it's basically to understand how many number of clusters, how many number of factors you should be selecting, what is the optimized. So you usually see where these green and the black line converge, and the number of greens which are there before this. So obviously this is cut off over here, but this plot should be till here, and obviously there is only one which is before that. So the optimized K, that is number of factors over here, looks as if 1, but still because we want to show it, so we'll go beyond that. Right, so we'll say fit 11 allocation sign and fact anal, that's the functionality we're using, USA, comma 1, because we found that there was only one optimized factor count. Rotation is equal to varimax, right? You can say print of fit 11 comma digits is equal to 2, and cutoff, the cutoff value beyond which you are saying that the component should be part is 0.3, that is you are specifying. Sort is equal to true. Right, so these are the various columns in the data. You said to create one factor, so only one factor has been created, the sum of square of loading and the variation, right? The test of the hypothesis is that one factor is sufficient, right? That's the hypothesis which is running over here. The chi-square statistics is 9.15, which is very high, and the corresponding p-value is 0.01, which obviously is very low as compared to the standard cutoff p-value, which is of 0.05. So obviously what it says is that this is significant, and this makes sense, right? Okay, now you can plot factor 1 by factor 2 also. So you can say a load allocation fit $11 loadings, and in bracket you can specify box bracket comma 1:2, that's from 1 to 2, and script out of bound, okay, because we just have, I guess, one factor. I just want to say one plot load type is equal to n, and text load. Now we cannot do a plot factor 1 by factor 2 because we just have one factor in our data, right? For fit 11 we passed factanal USA comma 1, so we ideally told the algorithm to create one factor. And now when we are saying that plot factor 1 by factor 2, so it won't come out because we haven't created that, right? Still, as you can see on the screen, we'll just process the algorithm. So labels is equal to names, USA comma CX is equal to 0.7, right? So that's where they are standing. Murder, assault, rape, urban probe, but you just have one factor, you don't have two. That's why it is coming like that, and the index is just coming because of absence of the other factor. Okay. So as you can see on your screen, you already have made an call that you're going to take only one factors, because the number of green boxes before the intersection of the black and the green is only one. So you have said the optimized number of factors is 1, and correspondingly also you saw that when you did this, the hypothesis test said that your p-value is 0.01 approximately, which is less than 0.05, which is significant, right? So that makes sense, right? And again, an output of the same which we saw on the screen when we were doing it over here is shown over here. The chi-square fit statistics is very small. This indicates that the hypothesis of perfect model fit is rejected and the alternate hypothesis is selected. So what's the difference between a PCA and an EFA? The PCA is useful for data reduction method that can replace a large number of correlated variables, which is called as multicollinearity, with a smaller number of uncorrelated variables, simplifying the analysis. Whereas the exploratory factor analysis contains a broad range of methods for identifying latent variables or unobserved constructs that may underlie a set of observed or manifest variables. Again, you need to understand the perspective. Now, exploratory factor analysis is more often used when you're doing research wherein you're distributing survey forms. For example, we all know that the salary of a person is directly proportional to his experience or to his performance, but many times it is also dependent upon what your boss thinks about you. For example, if your boss called you in the evening for a late night drink because his wife had a fight with him and he wanted somebody to give him a shoulder and you were not there, and you refused saying that I want to go for a movie, And now this factor might come sometime in your appraisal when they are doing a 360-degree appraisal. So these are latent variables which are not directly observed, and obviously you require something which is called as a survey form, wherein somebody writes about what he feels about you, and that is then converted into a score and used as a latent variables. So many times people in analytics or we just learn a technique without understanding why is that technique used, right? So this technique is primarily for market research guys and those who are analyzing small sets of data and trying to really see and validate as to why certain things are happening, more on the causal analytics side and not on the predictive analytics side. So the goal of PC is typically to summarize the data and reduce the dimension, whereas EFA is used as a hypothesis generating tool and to understand the relationship between large number of variables, but not when the data is very large. The PCA is primarily concerned with explaining the variance. EFA tries to explain the covariance or the correlation of the observed variables by means of a few factors.